identify the number of nodes in this. So as we could see that there are only two nodes in this circuit. Number one is this node, as two components are being attached to it, so it is v1 we would name it as, and the other node this as this resistance, and three components are attached, so we will give it a name of v2. So the second point is the reference node. So we could see that here is the reference node is only a single node here on which all the common point has been attached. So the second point which comes is identify reference node. Okay, so the third point which we will do is we will apply KCL rule on this circuit. First we will find voltage across V1. As you could see, resistance 2 ohm is connected across V1. Okay, so and this we could say as reference node. So as we give name of reference node V0. Okay, so uh, as resistance 2 ohm is connected between reference node and V1, so we did its equation as V1 minus V0, V1 minus V0 over 2 as over 2. Why we write over 2? Because the formula of current is V over R. So V1 minus V0, V1 minus V0 voltage over resistance. Over resistance is 2. Okay. So now, as you could see, 5 ohm is also connected with V1. So we would take V1 as higher potential because we are concerned about V1 voltage. So we will be supposed to be at higher potential. So V1 minus V2, because V1 is higher. V1 minus V2 over 5. And see, the current of the battery is coming towards the node. If the current of the battery is coming towards the node, it is taken as positive at the other end of the equal sign. So as it is coming, the arrow is upward towards the node, so we will write it as 3.1 ampere. Now what we will do is this will become our first equation, and so now we will find the voltage across V2, voltage across V2. Now V2 is at higher potential and V1 is at lower potential across this resistance. So we will write it as V2 minus V1 over 5. V2 minus V0 over 1. We will write it as V2 minus V0 over 1. And now the current is going away from the node. The node is here and the arrow is towards downward. So we will write it as at the equal sign with minus sign and minus 1.14. Okay, is that clear? Okay, now what we will do, now we will solve these equations to solve equation number 1. Okay, so V0 is 0 across the reference, 0 across the reference. So we will put V1 minus 0 over 2 plus V1 minus V2 over 5 is equal to 3.1. Okay, so the equation that will become is 5 V1 plus 2 V1 minus 2 V2, and it will become as 31, and further we will solve, so 2v2 is equal to 31. This will be our equation number A. Okay, now we will solve equation number 2. Solve equation. Okay, now we will simultaneously solve these two equations, and we will get the value of v1 and v2. Okay, so let's solve the equation. Multiply it by 7, this equation by 7 and minus 42, 52.5. Okay, so V2 will become 1.89 minus. So if the minus sign come with the voltage, it will be taken as positive, because let's so it will be as V2 is equal to 1.89 volts. Okay, so we have founded the voltage across V2 which is equal to 1.89. okay, now let's find the voltage across V1. So put the V2 value in question number A. Okay, so it would become 7 V1 minus 2 V2 is equal to 31. The value of V2 is 1.89, so put it in 1.89 is equal to 31. 7 plus 3.78. V1 is equal to 34.78 divided by 7. V1 is equal to 4.96 volts. So we have founded the voltage between both the nodes as V1 is now 4.96 volts, and we have found the voltage across V2 which is 1.89 volts. So this was our lesson topic today. I hope so you have understand the